Hello everyone. Today's video is a demonstration of the ODOT PLC-DU03L acting as a Modbus TCP client. We will continue building upon the previous I/O bus video to explain. The main purpose, when acting as the client, is to light up our DT222F for a more intuitive viewing experience. First, we log into the PLC. After logging into the PLC, we add the protocol, Add Modbus. After adding the Modbus protocol, we click on our new client. After creating the new client, we modify the settings here, change it to TCP. Then here we need to change it to the server's IP address. This server is a server emulated by my computer. Enter 11. Here it becomes our computer's IP address. In the point configuration section, we add some points. We'll simply add a few here. For example, I'll enter DI, read discrete inputs. We read 8 length starting from 0. DO represents outputs. Write multiple coils, also starting from 8 length. AI is for reading inputs. Length I'll also set to 8. AO means write multiple registers. Length is also 8. After saving, we note down the addresses here. Then here, remember to add bus_Modbus client within the network. Here we set up an event trigger for a connection. Here, set it to 1. After setting it to 1, our main goal for the demonstration is to make our DT222F light up more clearly. Click Variable Assignment Mode. Select IEC address. Its QW0 corresponds to an address of our DT222F. Here we directly input the right register is QW11501. Here input our IW11501. Then we can add other variables. Missing word. And here the discrete variables, 8 words. I'll just use bytes for demonstration. Select byte, TO byte. Here we directly input QW11501. The discrete address we can check is X23000. Directly write it as byte IB23000 is fine. After saving, deploy it again. After deployment is complete, we set the program to monitor. At this point, our connection is not yet established. Then we open our Modbus slave. This is my simulated server. Then connect here. After connecting, you can see it shows OK here, indicating it's connected. Then I can directly write, assign a value here, let the program auto-increment by 1. The value here changes, including our indicator light also changes accordingly. If we turn it off, it directly becomes 14. Then our output here, input the value 44. The value 44 has come through here, including our input of 8 bytes here, set 1, set 1, that is 3. This value comes over for this byte. For these 8 bits, I want to light them all up, input FF. Here, 81 come through. Change it to a 0. It comes through. Then I turn off the DT222F from earlier. You can see all the indicator lights go off. Then this video demonstration ends.